All right, folks, this is the solution to the ice fort question. So just to be clear what's going on, this is Brad. Brad is launching snowballs up here. This is Kim in this fort down in this bunker. Um, and we care about the snowball that Brad is launching, so Kim can be defensive. So you've got a speed and an angle. So the first thing you're going to do, you know the drill, is say that the horizontal speed is 18.7 cosine of 36, which is 15.13 meters per second. And Vy is 18.7 sine of 36, which is 10.99, or pretty much 11 meters per second. And then cross out the 18.7 because we've used that information. All right, so question number one is calculate the time at which the snowball reaches maximum height. So even though this sounds like it's about a location, we don't know what that is. We just know it's bigger than 2.8. But what we do know is that for a split second, the Vy is 0 because it's transitioning from heading up to heading down. Okay, so that means we are going to look at the velocity function for Brad's snowball. We want the output of the velocity in the vertical. We want the output to be 0. The initial velocity, up, only the up part. So that's why we crossed out the 18.7. You're never going to use that again after you've found your over and your up. And they're on Earth. So we're going to subtract 10.99 from both sides. And then we're going to divide both sides by 9.8, negative 9.8. And you get a time of 11 divided by about 10, a little bit over 1, it looks like 1.12 seconds. Okay, so max height is setting the vertical velocity equal to 0. Question B, calculate the max height, plug and chug if you've got everything set up in place. All right, he did not start on the ground. His snowball started with a height of 2.8 meters. He spent his energy building his snow fort up. Again, only use the vertical speed here because that's the only part that can carry you up. And we're going to plug in the time that we found, 1.12 minus 9.8 times 1.12 squared over 2. And that is 8.96 meters. Which is, I gave it way too much. I mean, that's a hefty snowball. He must have a, tennis ball launcher. That's 25 miles an hour-ish. Okay, so that's a pretty massive max height. This is, to me, the tricky part. Calculate, so if you get this, awesome. Calculate the time that it impacts the wall of Kim's fort. So go back up to your picture. We want this time. Do we know H? No, we don't. Do we know the horizontal distance? Yeah, we do. We know that it has gone 33 meters to get to the fort and an additional 10 meters to hit the wall. So what we know is that the X location is 43 meters. And so you're always going to use the horizontal position function. I mean, you're never going to use the horizontal velocity function, right? Because it's constant. So the output of the horizontal position function is 43. It did not have a head start horizontally, only vertically. So it didn't have a head start this way. V naught in the X direction was 15.13. We're looking for time and it's not accelerating horizontally. All right. So divide both sides by 15.13 and you get a time of 2.84 seconds. Check your work. I highly recommend on the test that you record the times you find on the diagram. You don't have to, it's not required, but this, running out of space here, or colors or whatever, that we found to be 1.12. Be careful, don't take that time and double it. If I'd asked you to find the time on the ground, doubling that time would give you the time it's here. So that's 2.21 seconds. We didn't find that yet. I think that's the last question, but this time is 2.84. Okay, so it might be helpful to just kind of keep a running total of anything you have found just to make sure that it's making sense, right? 2.21 and then more time elapsed, 2.84. But it's speeding up here, right? So these times are going to be more compressed because it's traveling more distance. Like, I don't know that this is drawn to scale, but hopefully you know what I'm talking about. Okay. Then how far below ground the snowball impacts, distance h. So, okay, that again, another reason it's nice to label what you know here. 2.84 seconds. We know the time, we don't know the vertical location. So let's look at our vertical position function. We're looking for the output, we don't know it. It started out 2.8 meters above the ground, headed up at 10.99. And we're not solving for t here, we know the time. And we're on Earth. So you got 3 terms, and if you add those up carefully, you get negative, which is good because we knew we were below the ground because we were inside the fort. Okay, great. And then E says find the time that it spends inside the fort. So this is, I guess the point of this question is, this is the time from whatever this is, which you don't know, to 2.84. That's the time Kim has, I guess, to deflect it or catch it or whatever. That's the time it's inside her fort. So we want the time that it starts to be in the fort. The fort is below ground. So this means it has kind of hit no altitude, right? So if this were the baseball on the back field, it has hit the ground. But since Kim dug a hole in the backfield, that means that, you know, y equals 0, but it's still going to keep going. So we want, at that point, it has no altitude. So the output of the function is 0. It started at 2.8, headed up at 10.99. We don't know this time. That's our unknown. Minus 9.8 t squared over 2. All right, and we're looking for the time. So RA is, you can put this in your calculator, minus 9.8 over 2. It will do that for you, but hopefully you know by now that's minus 4.9. This is our B. This is our C. And you get 2 times. Remember to record both times. I was writing that note on some of people's homework today. So please record both times. I will take off on the test because if you say, well, I know the minus time doesn't make sense, fine, but you are deleting information that you have, or you're omitting information. It's helpful to know in case you have to go back and, average these 2 times to get the time at the peak or whatever. Please, that's my rule is you have got to record both times, even if you know one of them doesn't make sense. All right, let's go back and put that up to make sure that, so this time is 2.47. Yay, that makes sense. That's good because 2.47 is less than 2.84. So what we want to know is, hey, how much time does Kim have to catch it or something before it hits the wall? So the change in time is going to be when it hit the wall minus when it started landing in the going into the fort below ground. So she has not a whole lot of time. 0.37 seconds. All right, I really like this question. This was a question on a test. It really tests, understanding whether using velocity or position and horizontal and vertical. So that's good practice, and thanks for listening.